Every day, billions of people across the globe start their mornings with a simple ritual: brushing their teeth. But have you ever wondered what goes into that small, minty tube we often take for granted? Toothpaste is a fusion of chemistry, engineering, and meticulous quality control, and its journey from raw rock to finished product is nothing short of fascinating. Every year, more than 20 billion tubes of toothpaste are manufactured, and at the heart of this global operation is a complex process that ensures consistency, safety, and effectiveness in every squeeze dot. We begin our journey at the Colgate Palmolive facility on the outskirts of London, one of the largest toothpaste factories in the world. Colgate, now present in over 150 countries, has a legacy stretching back to 1806, when English immigrant William Colgate started a modest soap and candle business in New York. By 1873, the company had revolutionized dental hygiene by introducing toothpaste in a collapsible tube, major advancement from the old-fashioned jars. This innovation, combined with a scientific focus on improving oral care, turned Colgate into a household name by the mid-20th century, especially after introducing fluoride-based toothpaste to fight cavities. Modern toothpaste starts with a surprising ingredient: rock. Minerals like silica, calcium carbonate, and sodium bicarbonate are the core abrasives that scrub plaque and food debris off your teeth. These are delivered to the factory in large sacks and drums, alongside other ingredients, such as sodium fluoride, the active cavity-fighting component, detergents to create foam, humectants like glycerin to retain moisture, binders to control consistency, colorants for visual appeal, and flavorings most commonly meant to make the experience pleasant. Once inside the factory, all these components are carefully measured. Some are dosed in tons, others in grams, depending on their concentration and function. They are poured into enormous high-speed mixers capable of blending up to 5 tons of material in just 5 minutes. These industrial agitators spin at dizzying speeds, up to 2,500 revolutions per minute, ensuring a smooth, uniform paste. At this stage, the mixture resembles thick cake frosting, but the similarities end there. The mixture is then gently heated in large aluminum kettles to stabilize the formula and activate certain ingredients without causing chemical breakdowns. Each batch can produce enough toothpaste to fill 30,000 tubes. The next step is one of the most iconic: adding the stripes. Those red, blue, or green lines we see in toothpaste aren't just for looks. They're a marvel of fluid mechanics and consumer psychology. Separate colored gels are added to the base white paste. These colors have no active function, but research has shown that consumers perceive striped toothpaste as more effective and trustworthy. To ensure the stripes don't mix with the base, viscosity, the internal flow resistance, is carefully controlled in the lab. If the mixture is too thin, the colors will bleed. If too thick, the paste won't dispense properly. Flavor is equally critical. Mint remains the most popular choice, and chemists blend essential oils like peppermint, spearmint, or wintergreen to achieve a balanced flavor profile. In some markets, exotic variations like lemon, cinnamon, or even charcoal-infused mint are developed. A dedicated department spends hours every day testing flavors and consistency. Each batch undergoes stringent quality control, including viscosity checks, microbial testing, and visual inspections to make sure it meets every standard. With the mixture perfected, it's time to fill the tubes. The paste is pumped through a complex set of pipelines into a filling machine that injects the product into preformed tubes. Different colors are funneled through separate channels, yet due to the carefully balanced thickness, the colors don't blend. Each tube is filled with exactly 70 grams of paste and then heat-sealed at the bottom. A batch code is printed, ensuring traceability and freshness. Filled tubes are then placed onto conveyor belts in groups of 15. The system automatically rotates them to align the branding and label. Any misalignment here could result in rejected packaging. After sealing, the tubes are grouped into boxes, each designed to hold 24 tubes. Properly sealed boxes proceed to final packaging, palletization, and global distribution. But how does all this chemistry and precision actually clean your teeth? Toothpaste performs two main functions: chemical and mechanical cleaning. Chemical agents like fluoride react with bacteria and neutralize acids, while the abrasive minerals gently scrub the surface of teeth, removing plaque, stains, and food debris. Detergents create foam, which helps spread the paste evenly, while humectants prevent it from drying out. Flavoring leaves your mouth feeling fresh, and the entire formula is designed to be safe for daily use over a lifetime. Denim pants, commonly known as jeans, are one of the most worn garments on the planet. But few people realize the extraordinary journey each pair takes before reaching a store shelf. Made from cotton fabric, jeans undergo an intensive transformation, involving agriculture, engineering, dyeing, weaving, sewing, and even lasers. What started as practical workwear in the 1800s has become a fashion staple and a $40 billion global industry. The story begins shortly after the California Gold Rush, when Levi Strauss started making durable trousers reinforced with copper rivets for miners. His creation quickly gained popularity, evolving from rugged utility wear to a symbol of style. Jeans begin their lives as cotton, which takes about 5 months to grow from seed to maturity. In regions like Mexico, vast cotton fields stretch to the horizon. Modern farms use harvesting machines that can gather in 5 minutes what would take a human an entire day. The harvested cotton is compressed into large bales. From every ton, only 400 kilograms is usable cotton fiber. The rest is seeds, leaves, and plant matter. At the processing plant, machines clean and filter the cotton, removing debris and extracting pure fiber. The clean bales weigh about 200 kilograms and can be used to produce around 325 pairs of jeans. But raw cotton isn't yet denim. It first has to be blended to ensure consistency, since every bale differs slightly. Then comes carding, a process where fibers are untangled, aligned, and combed into thin webs. These are stretched into thick strands and spun into yarn at high speeds, reaching up to 120,000 revolutions per minute to become blue jeans. The cotton thread must be dyed with indigo, a centuries-old dye that turns blue only after reacting with oxygen. The threads are dipped repeatedly into indigo baths until they reach the signature dark blue shade. They're then treated with cornstarch to stiffen them and dried, ready for weaving. The dyed threads are woven into denim fabric using industrial looms. For every 3 vertical blue threads, warp, 1 horizontal white thread, weft, is woven across, creating the diagonal denim pattern. Each loom can produce up to 3,000 meters of fabric weekly. Once the fabric is woven, it's sent to the cutting department. Computers map out patterns to minimize waste. An automated machine slices through 150 to 200 layers of fabric at once. Smaller parts like pockets are cut with die machines. A single roll of 450 meters of denim yields about 350 pairs of jeans. Fabric pieces are then transported to the sewing floor, where hundreds of skilled workers assemble the jeans. Each worker specializes in one task: sewing zippers, stitching pockets, or working on seams. Embroidery machines add brand logos at speeds of 2,500 stitches per minute. A single production line might use over 10,000 meters of fabric and 75,000 meters of thread daily to produce 6,000 pairs of jeans. Seams are carefully folded and stitched from the inside for a clean, invisible finish. After sewing, jeans go through modern finishing methods, including laser treatments. Guided by computer programs, lasers simulate wear patterns, fading, and even holes, all without water or harsh chemicals. These lasers can make jeans look like they've been worn for years in just an hour. Potassium permanganate is sprayed on jeans for bleaching, giving certain areas a lighter, worn look. The transparent spray is dyed purple, so workers can see where it's applied. The color disappears during washing, leaving only the bleaching effect. Washing is one of the most important steps. In stone washing, jeans tumble with pumice stones to achieve softness and faded color. Finishing touches include ironing, adding buttons, rivets, and branding labels. Finally, each pair undergoes inspection to ensure quality. After passing this test, the jeans are packaged and shipped to stores across the globe.
If you enjoy this video, make sure to like and subscribe for more updates. Share your thoughts in the comment section down below.